Good morning, class. Today we're going to be learning lesson 2-3 in our textbooks, which is all about learning how to apply deductive reasoning. We've already learned about inductive, so how is that different from deductive reasoning? Well, for deductive reasoning, you're going to use facts, you're going to use definitions, you're going to use accepted properties, and you're going to use laws of logic, which is something new. And these are going to be what you use to finally make a formal argument or conclusion. Where for inductive reasoning, we would make our conjecture just simply based on examples and patterns. So it wasn't necessarily anything that we could prove, but it was more what we could look at, and this is what we based our conjecture on. So we've already worked on inductive reasoning. Let's work on deductive reasoning today. Obviously, if we're given a fact or definition, you can't argue with those, or accepted properties that we already believe in. But laws of logic is something new. So let's go over two of those that we're going to cover today. The first one is called the law of detachment. And what the law of detachment says is that if the hypothesis of a conditional statement is true, then the conclusion is true. Okay? So that's the law of detachment, and we're going to look at a couple examples of those in just a moment. The second one is called the law of syllogism. And what the law of syllogism says is if, well, that pen's not working. There we go. If, let's say, something, we're going to call it A. If A is true, then B is true. So this could be any conditional statement. If something is true, then something else is true. Well, if I have a second conditional statement with it that says if B is true, then something else, we'll call it C, is true. If both of these statements are true, then I can make my own conclusion, and I can say that if situation A is true, then C is true. Okay, so if you have something that's true, then B is true. Well, that's the same as in the second statement. If B is true, then C is also true. So I can kind of infer from all of this using the law of syllogism that if the first statement is true, then the last statement is also true. Okay, so let's look at a couple of examples to really work on this thought process. So this first one is we're going to use the law of detachment to make a valid conclusion. So again, that law of detachment said that if the hypothesis of a conditional statement is true, then the conclusion is true. So here is my statement. If two segments have the same length, then they are congruent. This is my beginning conditional statement. This is the hypothesis. Two segments have the same length. This is my conclusion, that they are congruent. So I'm given that BC is equal to XY. That means the length of BC is equal to XY. Well, that's what my hypothesis was, that two segments have the same length. That's what I have here. So I'm going to write down my conclusion. I'm going to use a green pen. Since BC is equal to XY, that's what I was given at the end, and that satisfies the hypothesis of a true conditional statement, the conclusion is also true. So, if the conclusion is true, then I know that the line segment BC must be congruent to the line segment XY. Okay? A lot of this is stuff that you probably already do, but now we're putting it into words by using this law of detachment. Okay? Here's a second situation. This one says, if Anya goes to play for a softball team, she will have a jersey number. So that is our beginning conditional statement. And then it says, Anya plays for a softball team. So you probably can already guess, oh, well then Anya is going to have a jersey number. And the way that we're going to argue this is we're going to say that since the hypothesis of the conditional statement is true, meaning that Anya is playing for a softball team, then the conclusion would be true. Which means that we can conclude that Anya will have a jersey number. And that's it. That's kind of my conclusion here. All right. So those are just two examples of how we use the law of detachment to kind of prove our case and make a conclusion. So we're going to move on to some examples where we're going to use the law of syllogism to write a new conditional statement. All right. So let me give you an example. This first example says, if Parker takes biology next year, then Jonathan will be Parker's lab partner. So this is the if A meaning Parker takes biology next year, then Jonathan will be Parker's lab partner. I'm going to maybe underline these in different colors. So Parker takes biology next year, then Jonathan will be Parker's lab partner. Then my next statement says, if Jonathan is Parker's lab partner, which is the same as up above, then Parker will get an A in biology. So you can see here, really, I just have three different parts because two of them are being repeated. So I can say, since the conclusion of the first statement is the same as the hypothesis of the second conditional statement, then I can write the following. If Parker takes biology next year, then Parker will get an A in biology. And the reason why I was able to make this final conditional statement was based on the law of syllogism. Okay, so good job, Parker, for choosing to sit next to Jonathan. All right, let's do one more. This one says, if x is greater than 25, then x squared is greater than 20. The second statement says, if x is greater than 5, then x squared is greater than 25. Okay, so this is kind of weird. I'm looking here, and this conclusion is not the same as the second hypothesis. But I do notice that the conclusion of the second statement is the same as the hypothesis of the first. So they don't always have to be written in the other order. Okay, I can look here and see, oh, this is where they are the same, even though they're written in reverse order. So x greater than 5 is completely different, and so is this. X squared is greater than 20. So what I can assume, because x squared is greater than 25 is the same in both of these statements, here it is the conclusion, and in the first one it's the hypothesis, then I can say, if x is greater than 5, then x squared is greater than 20. And that's based on the law of syllogism. Okay, so you've done some examples now using inductive reasoning and also deductive reasoning. So on your own, when you come back to class, I want you to decide if the two following sentences are showing inductive reasoning or deductive reasoning to reach their conclusion. This first one says, whenever it rains in the morning, afternoon soccer games are canceled. The soccer game was not canceled, so it did not rain this morning. Are they using inductive reasoning or deductive reasoning to reach their conclusion? And the second one says, every time Naomi eats strawberries, she has a mild reaction. The next time she eats strawberries, she will have a mild reaction. So how are they reaching this conclusion? Are they using inductive reasoning or deductive reasoning? So come with your answers and any questions that you have when you return to class.